No.
Yes, go.
Okay. Right now. So we're the Emperor team, and so that's Andrew, JB, Hussein, and me, Yoshiki. And like I tried to briefly explain the other day, what we're going to try to do is improve a lot of the API and the usability of a tool called Emperor. And so just a little background. Emperor is an already rather mature project, and on its most basic sense, it's just a three-dimensional scatter plot viewer. And the reason why we use this, or one of the places where we use this a lot, is in microbiome data analysis as our main exploratory tool. And I just realized I'm covering the screen. So we use these a lot to color by the sample metadata that we have, to change the size, the opacity. You know, just look at all the metadata that you have with your samples in the context of your microbiome data set. So we use it a lot. And the problem is that the JavaScript API and the JavaScript design was really, really bad and was not ideal. So we decided to improve that. And it really became a problem when our boss, Rob Knight, was presenting these and was trying to show a plot with about 15 or 20,000 samples. And the browser would just crash. And in trying to figure out what was going on, it was just so painfully hard to debug. So, we had a lot of spaghetti code. We were not scaling very well, and I believe that this is one of the worst things that we had. Our boss factor was of 1, and for those of you who do not know what the boss factor is the number of people you have to have run over by a boss for your project to be bad. So, I don't know, we're all relying on just one person. And I think this is another horrible thing that we have. It was very, very hard to add new features and to efficiently test that this new feature was not breaking something else and that it was well integrated with the rest of the application. So our current architecture is non-existent. The documentation and tests for JavaScript non-existent. Like this was all probably a 3,000 line JavaScript file that had all the code embedded in there. It was rather horrible. So what we actually did is we thought out a new design. We came up with all the core objects. We came up with a really good architecture using the model view controller paradigm. And after these last few days, we added 11 files, about 2,000 lines of new code that's all very well tested, though not all of it is tested. So there's still more tests to be added. So we're now at 849 lines of test code. And we also were able to, earlier this morning, create a proof of concept that this is actually going to work. Because we had all of these designed, but we were not sure that once we plugged everything together, it was actually going to work. And so if you guys want to go to the GitHub page of Emperor, it's in github.com/biocore/Emperor, and that's a pull request with all the changes that we did during this hackathon. So if you actually want to contribute to it, yeah, just you're more than welcome. That would be awesome. This is the architecture of the application. I don't know if you want to talk about it or.
Yep. It's, I mean, probably most of you are familiar with the model view controller. Well, the model just holds all the data that is going to be shown. The view is actually how, for the application, this data is seen. So, for example, you probably have a lot of data, but you want to just see a subset of them. And then you have the controller, which is actually what drives the changes. So in our specific case, let's say we have the plottable objects which are on the samples, those spheres that we have on the screen. And the decomposition object is all the information of the actual analysis that you have done. So for example, you have all the metadata for the samples, you have all the coordinates for the samples, and I think that's all the information that we have for that. So then on the view, we have the decomposition view, which is actually a one-to-one mapping for the decomposition model. It's like how the system is looking at that object. So for example, I'm just gonna see the first principal component, or I'm gonna see the first, the third, and the five. So how I'm looking at it. The scene plot view is which is everything I'm gonna see. So for example, you can have two analyses we call biplots. So you are actually plotting the samples and the taxonomies to see if the taxonomy drives the differences between group of samples. So you can have multiple decomposition view objects, and then you have that on the same plot view. And on top of it, you have the emperor controller, which is the guy that is there controlling that everything plays together nicely, and we have something on the screen. So this is the design that we came yesterday, and we were really enthusiastic. It's really modular, it's really fun, it's really nice. So it's gonna work. So yeah, see it now.
So we have this demo, and you know I guess it'll be useful if I just show you how a current interactive plot looks, and you can just go to emperor.colorado.edu and just get one of these plots. So that's the current way that it's implemented, and it works, and that's the way we ship it. But the JavaScript code is horrible and unmaintainable. So essentially, where we want to get to is here, and where we were actually able to get is to a point where we have these rather modular architecture, such that we can, if we want, have more than a single view. And this is very useful because each one of these groups of points, and I'm not sure this is super clear, but this is a plot, this is another plot, and this is another plot, and this is another plot. So we have 4 different plots, and the reason why this is super useful is because you could be looking at the same data colored by different attributes or presenting different dimensions, but of your same data set. And this is a rather common use case when you're doing exploratory data analysis of microbiome data. So this was fine. And you know, this is the way it works currently. But in a real use case example, you're probably doing your analysis using a tool like IPython or the IPython notebook, I guess the Jupyter notebook now. So you actually want to have these embedded and available through some sort of Python API. And we were able to put together these very simple piece of code where you actually are loading, and I'm not sure, you can view it, but what you're doing is loading an object called ordination results from scikit-bio. Scikit-bio is a toolkit for biological data analysis that we're working on. You load all of your metadata, and then you initialize your emperor object. And with the rich display system that the IPython notebook has, we're able to simply put this together within the IPython notebook and just load any kind of arbitrary data right now. So I don't know, we thought this was very cool, and this on itself is a major win for us. The way we were doing it before did not allow us to do things like these, because reusing and trying to rewrite things to be useful for these cases was very hard. So I guess that's the demo. And the next steps, we're planning on adding support for tetrahedron plots, triplots, interplots, and to keep using this project in a lot of our other projects. And hopefully, these will also serve for you guys to see if this fits a use case you have. Maybe you can start also using Emperor. And just horrible disclaimer, if we were to win, we were planning on spending the $500 beer and food for everyone who wanted to join us. So that's all we have, and thanks.